So guys, that's what you are doing for lab 13. So inside this flask, you are placing 10 ml of vinegar. It's diluted vinegar. And then inside the burette, you have got sodium hydroxide with a concentration which is known. Around, I think it's around 0.19 something. Then you're adding an indicator which is called phenolphthalein. Now this indicator turns pink when the solution is basic. So what you are doing in previous slide, you read the volume of an AOH. Read here. Then you open the tap, you open the valve, you have dropwise sodium hydroxide neutralizing the vinegar, which is acetic acid. At some point, you see the pink appears and then disappears. It comes and goes. Why? Because the pink is showing basic solution, which is coming from here, from NaOH. But then the vinegar, which is acidic, is going to neutralize the NaOH, the pink goes away. You keep adding droplets until pink remains, it's not changing. That means all the acid is gone. That means titration is done. So you read the volume of the burette, which is V2. So if V1 was here and V2 is here, the difference between these two shows the volume of NaOH which is used. So, are you with me so far? Do you have any questions so far? That's all, which is in lab 13. You just add base to neutralize the acid. When the color appears, read the volume. The difference between the initial volume and final volume shows volume of an AOH used.
What part goes up? Like, I'm just curious for when the experiment actually happens. What part goes up into? Does nothing go up? Does nothing go up into that part that's sticking down into the beaker?
No, just droplets. Nothing go up.
So it only drops out.
That's right.
So you're testing how many it takes to neutralize it.
That's right. Yes.
I see. Thank you.
Sure. Good question. So endpoint, that means end of titration, is a point that you have a very light pink which remains constant, is not changing immediately. Sometimes it remains for 60 seconds and that's long enough. It doesn't go back clear instantly. As I said, all we are doing, we are asking how much volume of sodium hydroxide is needed to get to endpoint. That means to get to consume all the acids in vinegar. And then you have molarity of an AOH, which is written on the flask. You just measure the volumes of an AOH by reading the burette. Can you calculate number of moles of an AOH? Well, how do you calculate number of moles? Is it fair to say that molarity times volume gives you number of moles? So molarity is here. Volume, you measured it, make sure the volume is in liter. Then you have number of moles. That's moles of an AOH. If I am looking at this equation, do you see the ratio is 1 to 1? What is the meaning of 1-to-1 ratio? That means you have equal number of moles used. For lab 13, you are using acetic acid with NaOH. This is the equation. And this results to the formation of NaCH3COO plus water. So in here also the ratio is 1-to-1. So if you have moles of NaOH, can you calculate moles of HCl? Yes. You see moles of HCl is 1-to-1. It's the same as moles of NaOH. You already have moles of NaOH here. So now you have moles of the acid. Now your acid is acetic acid. If you have moles of the acid and you have the volume of the acid, can you calculate number of moles of the acid? Yes. Number of moles of the acid. Again, it's molarity of the acid times the volume. Oops. You have volume of HCl, and you have number of moles. You can calculate molarity. Use the molarity of the acid, which is this one, times the volume. Make sure you use volume in liter. And this is number of moles. Then you can calculate moles of acetic acid. So guys, you already learned in chapter 6 how to convert number of moles to grams. If I give you moles of anything, you can convert it to grams. But if I give you grams of water, you can convert it to moles. How do you do that? You just use the molar mass. If I say 2 moles of water, 1 mole of water is 18 grams, right? That's molar mass of water. If I say 2 moles of water, you can multiply 18 by 2. You convert moles of water to grams of water, which is 36 grams. So 2 moles of water is 36 grams. In this case, you have so many moles of acetic acid. How many grams is that? Once you have done that, you're going to calculate percentage of the acid in vinegar. If you have grams of the acid, and if you have grams of the vinegar, you can calculate the percentage of the acid in vinegar. Now, apparently on the video, the students who did the video, they forgot to measure the mass of the vinegar. But I gave you the density of vinegar. I said density of vinegar is, assume it is 1 gram per ml. So once you have 60 ml, that means 60 grams. So number of milliliter and grams are the same when the density is 1 gram per milliliter. So you are using density of vinegar to convert volume to grams, and you have grams of acetic acid by this calculation. Then you can calculate percentage of the acetic acid in vinegar.
So it should be 60 grams, correct?
Good job. That was very fast. Good job. Yes. Good job. 60 grams per mole is the molar mass of acetic acid. Yes. So when you're doing your calculation, use this, listen to this Zoom recording, do one step at a time. I also wrote the page number on your procedure in the book. There is an example done in the book. Just follow the same step by step. It's not difficult at all. Any questions so far? Any questions so far?
For the third section between moles of hydrochloric acid and molarity of hydrochloric solution, it says divide by the volume of the hydrochloric solution.
Yeah, yes. See, if you want to calculate molarity, all you have to do, you have to divide the number of the moles by volume. Good job. Yes.
Yeah.
So let's see. Okay. Actually, I have an example for you. Let me go back. Where was I? Okay. Yes, if you divide number of moles by volume, make sure volume is leader and this is moles.
And when in the second one, when it says use coefficients in balanced equation to find, is that we're balancing the OH and the H because there's 1-to-1 ratio?
These are the coefficient.
Okay.
1 OH, 1 H makes 1 water, right?
Yes.
And then 1 NaCl. So your example also, which is acetic acid, is 1-to-1. So the number of moles are equal together. Any other questions, guys? All right. So I'm going to do another an example for you, which is exactly the same as calculation you have to do, except I'm using hydrochloric acid. In your calculation, you're using acetic acid. So what is the molarity? That means what is M? Of this acid. We want molarity of hydrochloric acid. If 18 ml of 0.25 NaOH is used, so the volume of NaOH is 18 ml, and the molarity of NaOH is 0.25 m, and you have used 10.0 ml of the acid, so the volume of the acid in this case is 10.0 milliliter. Guys, because I have molarity and volume of the base, can I calculate number of moles of the base here? Remember, that was the plan we said. Calculate number of moles of the chemical that you have volume and molarity. Number of moles is volume times molarity. The volume is 18 ml. So can I write 18.0 ml? And can I convert this to liter? And every 1,000 ml is 1 liter. So that's the volume. Times molarity. What is molarity of NaOH? 0.25 moles per liter. So this will give you number of moles of NaOH. I can cancel liter and liter, milliliter, ml, and ml. So are you going to get 18 times 0.25, which is 4.5? 4.5 times 10 to minus 3. Is that what you get? So that gives you moles of NaOH, yes? Now, you saw the reaction. You have to write equation to relate number of moles. Can I say, did we say NaOH reacts 1-to-1 with HCl to give you NaCl and water? So the ratio is 1-to-1. 1 mole, 1 mole, 1 mole, 1 mole. That means number of moles, that means number of moles of these two are equal together. So can I say number of moles of HCl is equal to number of moles of NaOH, which is equal to 4.5 times 10 to minus 3 moles. Can I say that? So we have number of moles of HCl. We want to calculate molarity. Guys, how do I calculate molarity? Number of moles divided by volume, right? What is number of moles? 4.5 times 10 to minus 3 moles. What is the volume of HCl? 10 ml, milliliter. And can I say, if I divide this by 1,000, I get 10 to minus 3 liter per ml. So ml and ml will cancel. 10 to minus 3 with 10 to minus 3 would be canceled. 4.5 divided by 10 is 0.45. On the top, we have moles. On the bottom, we have liters, so moles per liter. Let's see if we got it right. And then I'll let you ask questions. Okay, let's see. Yeah, 0.45. So, do you have a question? Anybody?
I have a question. So after you figured out that the moles of sodium hydroxide was 4.5 times 10 to the negative third, to then figure out your molarity of hydrochloric acid, what was that step? One more time. What did you do to get to that point? Did you
Actually, here,
see
molarity is number of moles divided by volume in liter.
Oh, that's right.
All you have to do.
Okay.
Molarity is number of moles divided by volume in liter. Same thing that you mentioned on previous problem. Anybody else? Any other questions, guys?
Not from me.
I'm sorry?
Nope.
So that 4.5 times 10 to the negative third wasn't sodium hydroxide. That was of hydrochloric acid.
Right.
Oh, okay.
It's not the same thing.
So the moles are the same because it's a 1-to-1 ratio, correct?
Excellent. Yes. If you look at this equation, do you see you need only
Thank
one
you.
HCl, one NaOH to make one NaCl and one water. So you write a balanced equation that determines the ratio between number of moles. It depends on the acid and base. In some cases, the ratio is not 1-to-1. Then we have to use the ratio between number of moles to convert number of moles of one into another. I think I have an example. I'll give it to you. Any other questions, guys? Okay, let's see if I have another example. Yeah, actually, this is an equation. Do you see the ratio is not 1-to-1, it's 1-to-2, right? So once you convert number of moles of one, which is number of moles of KOH in this case, you have to use a conversion factor. Conversion factor is 2-to-1 to calculate number of moles of the acid. So go ahead, go guys.
Dr. Fard, you might have mentioned this previously, but the 1.00 molarity, is that actually like the moles?
No, molarity is number of moles per liter.
Okay, but we have to calculate the moles to get the molarity of the other.
Excellent.
Okay, thank you.
Thank you. Good question, though.
So for this one, it looks like we still have two OHs to two hydrogens though, because isn't it H2?
Correct. The ratio is 2 to 1. Yes.
Why is it 2 to 1 instead of 2 to 2?
Well, do you see this is providing 2H plus?
Yeah.
And if I take two of these, this will give you 2 OH.
Right.
Then you get 2 water. You see that? Number of hydrogen ions, see 2H plus needs 2 OH minus to make 2 water.
Right. So isn't that a 2 to 2 ratio, or is that still 2 to 1?
No,
Oh.
here. What is the number here? 1. What's the number here? 2. So it's 1
Oh,
to
I see now. Okay.
Good job, Victoria. Victoria got it. Good job. Good progress, guys. Let's see if you got it correctly. Is 50 ml 0.0550 liter. Another word, do you divide 50 by 1,000 to convert it to liter? And then molarity is 1 mole per liter for KOH. So it is 1 KOH per liter. Now you are canceling liter. That will give you moles of KOH, but we want moles of sulfuric acid. I need a conversion factor. Is it fair to say that I should write moles of KOH on the bottom to be canceled with moles of KOH on the top? According to the equation, every 2 moles of KOH needs 1 mole of sulfuric acid. So by doing this, now you have moles of KOH converted to moles of sulfuric acid. And I can get the volume by using this information. What is the meaning of 2 mole per liter of sulfuric acid? It means there are 2 moles of sulfuric acid in 1 liter. So that gives you a number of liter of sulfuric acid. And now you can cancel liter, go to milliliter. This is doing problem by unit conversion factor in one equation. You don't have to do this if you don't like it. Do the same way we did it before. First, calculate number of moles of KOH. First, calculate number of moles of KOH. Then, look at the ratio converted to number of moles of sulfuric acid and divide that by volume, or divide that by molarity to calculate the volume. You can choose any direction, any approach that you want, but this is the shortest approach. Using conversion factor simplifies your life, avoids error. Any questions, guys?
My only question is that middle section, the 1 mole of H2SO4 divided by 2 moles of KOH, that is the ratio, right?
Right, it's coming from this. Every 2 moles of KOH needs 1 mole of H2SO4.
Gotcha. Thank you.
This is 1 mole. Sure. You're asking good questions. You're helping others by asking good questions.
I guess my only thing that I'm kind of getting confused on is that they're just doing the molarity straight to moles. Is it because it's a straight conversion? Like the 1.00 mole? I feel like that's just being taken from the problem, and that's 1.00 molarity.
Exactly. See, we always show molarity with capital M, which means mole per liter. And we also show moles with N, which is moles. And how are these two related? By volume. Number of moles is molarity times volume. This must be in liter. So make sure not to confuse molarity.
Which is why it's over 1 liter, because it's, gotcha. Okay, that makes way more sense.
Perfect. Thank you for asking.